Hey all, welcome to Homeschool, and we are with the chapter Light, Reflection and Refraction. See, we covered everything about reflection. We spoke about reflection and its laws. After that, we went for studying the spherical mirrors, concave convex mirror, image formation by spherical mirrors, that is their ray diagrams. And after that, we studied mirror formula, magnification, and some problems we have solved. And that was one part of a chapter. And coming to the next part of the chapter, that is refraction. Okay, and I am assuring that this is the most wonderful process that is there in our nature. Very interesting process, very interesting phenomenon you are going to study. And when I was studying this thing, it created lot of interest in me. Okay, and so that I have studied this topic in depth and I understood so many things that existed very beautifully around us is just because of refraction. Okay, and I am here to share my knowledge about the refraction. Okay, that is there for your 10th level. Fine. And one thing I can promise you is, after watching this video, definitely you get a kind of smile in your face. You feel that the topic is really very interesting, right? So I am here to make you understand everything in detail about the refraction, and watch the video till the end. So definitely, if you want to have that happy smile, a smile of satisfaction, a smile of understanding on your face, definitely you have to watch this till the end with utmost interest, right? With this, I am starting the topic refraction. See, before I give the definition of refraction and how it happens, why it happens and everything, let us just try to observe some real life situations. Okay, can you see this? A straw that I am keeping in a glass of water. So how does it look? It looks as though in the water it is broken. Yes or no? Can you be able to observe the straw being broken once it enters into a water? And in water, the straw looks little bigger than the straw which is there in air. Yes, say outermost atmosphere is full of air. So I call this medium as air. Say from air, the straw is entering into a water, and in a water it is looking very different. It's looking as though it is broken, but in fact it is not broken, right? Why the straw is looking like this? Why it is looking as though it is broken? And why the size of the straw is little bigger in water medium compared to the straw that is there in air medium, right? See, here I have a lemon. Okay, I actually took two equal sized lemon. Okay, two equal sized lemons. One lemon I have put it in a water. See the sizes of the lemon. Actually, the sizes of the lemon was same when I took it. Okay, but one of the lemon, when I put it in a water, the lemon that is there in a water is appearing very big. Okay, but this, you see, this is small lemon, but the lemon that is there in a water is looking very big. So why is something that you put in a water looks big normally compared to the original object, compared to the original thing, right? So why is this happening? See, didn't you get a doubt on this? In a normal life situation also, anything you put it in a water and see, it looks bigger compared to its original size, isn't it? And one more situation I will show you, very interesting. Actually, in the olden days, this particular thing was used as a magic. Magicians used to use this particular thing to fool the people, but you can't fool a person who knows science, right? So I am showing that particular thing now, which magicians used to fool the people long back when they were not knowing any science. Anyway, this particular experiment you cannot observe in a video. You can do it at your home. Okay. See, I have taken a coin and I have put it in a bowl. Okay. And I have put it in a bowl, and I am holding this bowl in certain angle that I cannot see that coin. Okay. See, I am holding the bowl like this, and in this position, in this direction, I can't see the coin where it is. But I'm not changing the position. Okay. If I see like this, I can see the coin. Okay. If I hold the bowl down, I can see the coin. But at this particular position, okay, I cannot see the coin. You can try this right now at your home. You can pause the video, get a coin and a bowl, put the coin in a bowl, hold to this direction so that you cannot see the coin. Okay. And then pour a glass of water. You know what? I can see the coin. I can see some part of a coin. Initially, when there was no water, at this particular height, I cannot see the coin. I couldn't see the coin. But as I poured the water, I could able to see some part of a coin. So this was the thing magicians used long back to fool the people. But nowadays, there is a science involved in this, right? Say all these real life situations, involve a concept called refraction. Why does my straw is looking as though it is broken in the water? It is because of refraction. And why does the size of the lemon appear bigger in water? It is because of refraction. And why I can see a coin the moment I pour water? Initially, I was not able to see at a particular direction. But as I poured the water, I could see a coin. What is involved in this? What is the science involved in this? Refraction. Right? Say like this, in many situations, refraction is the concept involved. See, we see the TV screens, it's because of refraction. We wear specs, right? The concept involved in specs, the concept involved in the visibility through specs is a refraction, right? So this is a wonderful phenomenon that is taking place around us in a day-to-day life. So this phenomenon is what our refraction. Let us try to understand what actually a refraction is, and also let us understand what is the reason behind these things that I have shown just now. Okay. See guys, we all very well know that light travels in a straight line. Okay, and it travels with a particular speed in a particular medium. Okay, so the very first fundamental point about light we have already studied. Once again, I am revising you. Light always travels in a straight line. Okay, straight line with some speed. It will travel with some speed. Okay, in a particular medium. In a particular medium. Okay, say for example, in case of vacuum, what do you mean by vacuum? Vacuum is an area which does not contain anything. It will not have any air, it will not have anything. It's an empty area where air is not there. It's an empty space. So in an empty space, that we call it as vacuum. Okay, in case of vacuum, the speed of light is 3 into 10 to the power of 8 meter per second. I mean, per second, light will move with the speed of 3 into 10 to the power of 8 meters. In 1 second, it can cover this much distance. Okay, so this is the speed of light in case of vacuum. Okay, in case of air also, the same speed we will consider. Okay, so anyway, vacuum is different. Vacuum is the area where even air is also not there. Empty space. Okay, and air, it will have some molecules, right? Oxygen would be there. So many gases would be there in air. Okay, speed of light is not exactly this much, but approximately this much. So even in air also, the speed of light is 3 into 10 to the power of 8 meter per second, guys. Okay. And if I change the medium, you know what? In case of water, I'm talking about speed of light in case of water. Okay. And in case of water, it is 2.5 into 10 to the power of 8 meter per second. In case of glass, you know, all these are the transparent medium. Yes or no? In these particular materials, light can travel very comfortably, very nicely. But you know, in different medium, light travels with different speed. That is very, very, very important point to keep it in mind for this particular phenomenon. Okay, see, in case of vacuum, the speed is this much. In case of air, the speed is this much. In water, the speed of light is decreased. Did you see? Light will pass in water, but not with very much high speed. It passes little slowly compared to air. That is, this much is the speed of light in case of water. And coming to the glass, the speed of light in case of glass is 10 to the power of 2 into 10 to the power of 8 meter per second. Okay, the speed of light is much more decreased. Can you tell me why? In case of air, you have all gas molecules. And there are so many spaces between gas molecules, guys. There are so many spaces, no? So light can easily pass. There are no much disturbances, so it passes with high speed. Water is a liquid, so molecules are quite near in case of it's a liquid, no? We all have studied in our basic classes water, the spaces between molecules is little lesser compared to air. So light finds some disturbance to move freely because less spaces are there between molecules, right? And glass is what? Solid. That means the molecules are much closer. There are no much spaces. So the light passes through a glass, no doubt, but it travels with less speed. Okay, so that's why different mediums have different speed, you know, for the passage of light. Okay, fine. So when you have difference in the speed of light, once the medium is changed, the direction of light also changes, guys. Okay, so the second point that you have to remember is once the medium changes, you know what happens? Speed of light that is traveling in a medium, that is traveling, changes. Yes or no? Changes. If speed changes, what happens, guys? What happens? Direction of light that is traveling also changes. So this point is very, very important to understand. If you could understand this point, you know, actually this itself is refraction. Okay, so let me explain you more clearly here. Say I am taking one medium here. This is air. Okay, and below this you have water. Okay, say this is the interface. This is actually what? Boundary. This I call it as boundary. Definitely two mediums are always separated with boundary. Say for example, I am taking this. Right, say this is a air. Outside of this particular glass is completely air. This is one medium. Okay, and you know, till here I filled with water. Till here, till this mark of water, it is air medium only. Okay, and this is a boundary, right? So here the mark of water that you see, the margin of water, so that is the boundary between water medium and air medium. So definitely when two mediums exist, there is a boundary. This boundary is the one that actually separates air from water, right? Say this is air and this is water. Fine. And you know, some light ray is actually traveling in air and it is coming and hitting the boundary, the water boundary that is there. Okay, and now this is a water. From here, the water medium is there. It is water. Only till here, the air is there. From here, you have water. Okay, so this is my incident ray, some light ray, right? That is coming obliquely. Obliquely in the sense what? This incident ray is actually coming obliquely. Okay, what is the meaning of the word obliquely? It is coming slantly. It is not coming like this straight away. Okay, it is coming making some angle, right? When it is coming slant, it can make some angle here, right, at the boundary. So that is what we mean by light ray coming obliquely. Right. So what you normally expect, this is what the direction of incident ray that is coming from air. In air, it is traveling with some speed. In air, the same light ray is traveling with 3 into 10 to the power of 8 meter per second. Okay. Once it reaches the point of water, what happens? Will it travel in the same direction with the same speed? Normally, what we expect, light will travel in a straight line without changing its direction. Yes or no? So, normally speaking, this is the light ray coming and it goes like this, we think. But, see, the medium is different. What I told you, the speed of light is different in different medium. Okay, see, the light travels very fastly in air, but in case of water, the light is not traveling fastly. Its travel, the way it is traveling has become little slow. Due to that, what happens, I told you, direction of light changes. So, will this incident ray travel in the same direction in water? Never, because the speed automatically changes. It comes and strikes here. The moment it strikes here, the speed of light traveling in a water changes, so that, you know, this particular ray now travel like this. See what is happening here? Bending of light ray is taking place. See, light ray is not traveling in a straight line, guys. It has bent. It has bent. This bending of light, okay, when a light is traveling from one medium to another medium, this change in the direction of light, when the light is traveling from one medium to another medium, is called refraction. Okay, see how wonderful it is. It is happening in the nature everywhere, guys. The moment the light ray travels in a different medium, it does not go in that original direction. The direction is changed because the speed of light in another medium is completely different. Okay, say this is what we mean by refraction. Okay, so here if I draw a line perpendicular to this, you know, this becomes our normal. This becomes our normal, okay, and this line we will call it as incident ray. The ray that is coming and hitting the boundary is called incident ray, and you know, it should have gone like this. This is a normal way of expectation for a light ray to go, but once it reaches the boundary, it bends, its direction is changed, and you know, this ray, now we will call it as refracted ray. It is called as refracted ray, guys. Okay, so there we said reflected ray. Yes or no? Say you had a surface, incident ray has come, hit, the same ray reflected. We call this as incident ray. This we called it as reflected ray in case of reflection. Same way here, instead of reflection, some amount of rays will get reflected, but this process also takes place along with the reflection, guys. See, any light rays when hit on any surface, reflection takes place. That is what you studied in the first part of the chapter. But along with some amount of reflection, you know, light rays when travel in another medium, the direction of light ray changes due to the speed of light is different in different medium. Okay, so this bending of light, this change in the direction of light is what we will call refraction. Shall we write that definition here? So what do I mention as a definition? The bending of light, you can copy down this definition. Bending of light or change in the direction of light. Change in the direction of light. Okay, when it is traveling from one medium to another medium is called refraction. Okay, so this is the very simple definition for refraction. Okay, so now let us learn a few more things in detail about the refraction. Initially, just I am going to rub all these things so you can better copy these things. Pause the video or take a screenshot. This is very, very important to know. See here, we understood the basic phenomenon why the light is bending here. Because once the medium is changed, the speed of light changes. That leads to the change in the direction of light ray. Okay, it has to go normally in this direction, but it is going like this. So we got to know this is called incident ray and this is our refracted ray. Okay, and you know there is an angle between incident ray and normal that we call it as angle of incidence, and the angle between normal and refracted ray is called angle of refraction. Okay, this much you should know. And one more important thing is here air is called rarer medium and water is called denser medium. So when do you call some medium as rarer and when do you call certain medium as denser? There is a thing that you have to remember. See, the medium in which, try to note this point, medium in which light travels very fast. Light travels fast is called rarer medium, guys. Okay, and the next point is medium in which light travels slow is called denser medium. So I have explained you the speed of light. Speed of light in air is 3 into 10 to the power of 8. It travels with very high speed. But in water, the light travels with less speed. Okay, so rarer medium and water is denser medium. Clear? Say among the two medium, I called air as rarer, water as denser. And remember a point that this is very, very important point, guys. Note down carefully. So whenever light travels from rarer medium to denser medium, you know what happens? The refracted ray, the bent light ray, okay, moves towards normal. The refracted ray bends towards normal. Okay, this is a very important point. Refracted ray, to which side it will bend? Refracted ray bends towards normal, guys. Bends towards normal. Clear, everybody? So light is traveling from rarer medium to denser medium. Then that point of time, the refracted ray moves towards normal. It moves this side. Say light can bend in two ways, right? One way is, see, it should go in this direction. This is the expected direction. But instead of that, it can bend this side or it can bend like this. Yes? So when does the bending takes place to what direction? That also is important to remember. So the bending occurs towards a normal when a light ray travels from rarer medium to denser medium. Okay, so now let me show another situation. Now I will take a denser medium here, okay, and here I will be taking some rarer medium. Okay, denser medium in the sense light is traveling with less speed, rarer medium light is traveling with more speed. Clear? And so incident ray, okay, that is coming, that is traveling in a denser medium with certain speed in a certain direction. The moment it hits the boundary between the rarer and denser medium, now this is a surface of rarer medium. The moment it comes and hits here, this is our normal. First to draw the normal. Okay, this is our expected route, right? This is our expected direction. It bends like this. It travels like this. You see, the refracted ray is moving away from the normal, right? This is our refracted ray. And this is our incident ray. So whenever incident ray, some ray comes and falls on a surface of rarer medium, bending of light takes place. But how is it bending? It is going away from the normal. Now, what is angle of incidence? The angle between incident ray and normal is called angle of incidence. And what is angle of refraction? Angle between normal and refracted ray is called angle of refraction. Okay, so the next point I will mention here is whenever light travels from which medium? From denser medium to rarer medium, denser medium to rarer medium, what happens? What happens here? Refracted ray bends or moves away from normal. These points are very important to remember. Away from normal. Okay? Right? So whenever light is traveling from rarer medium to denser medium, refracted ray bends or it moves towards, near to the normal. Okay, and here can you compare the angle of incidence and angle of refraction? In case of reflection, you studied angle of incidence was equal to angle of refraction, no? But here, can these two angles be equal? See, in this case, what happens? Angle of incidence is greater than angle of refraction. Yes or no? You can see angle of incidence is greater than angle of refraction because the refracted ray is more close to the normal, so very less angle it makes. Yes or no? And coming to this case where the light is moving from denser medium to rarer medium, you see this much is the angle of refraction, but you see the angle of incidence, it's lesser. So what I can say here, angle of incidence is lesser than angle of refraction. So this point is also very important to remember. Okay, so 2 points here. One is when a light is traveling from rarer medium, that is the medium in which light usually travels fast. From that medium, if it is entering to a denser medium, the medium where the speed of light is lesser, what happens? The refracted ray is more close to the normal. And here angle of incidence is always greater than angle of refraction. And coming to the opposite case, if light travels from denser medium to the rarer medium, what happens? The refracted ray moves away from the normal. Okay, so here what happens? Angle of incidence is actually very much lesser than the angle of refraction. Okay, and actually you might be wondering, why ma'am in this case it is moving near to the normal and in this case it is moving away from the normal? Yes, okay, we can remember. These 2 points are very important to remember for examination point of view. Okay, we remember. But what is the reason? The reason is actually not necessary for you, but I am going to tell here to have a complete deep knowledge on this. Okay, so why is a ray moving towards a normal? Is because, you know what? Say, this is the surface of water. Say, this is the final point where refracted ray has to touch. So here the target of light that is coming from this point is it should touch this point. Okay, I have set a target for light ray, guys. Okay, light ray is starting at this point and I have set a target for light ray to reach this point in 5 minutes. In 5 minutes of time. Okay, so what happens, say the ray comes very fastly in this medium air because the speed of light is very much high. The moment it hits, the speed gradually decreases. The speed gradually decreases, but it should reach on time, no? The light is actually very punctual, guys. If you set a time, no, it will reach at that time. Okay, if you set a time 5 minutes for reaching at this point, it will exactly reach within 5 minutes. Okay, light is not like human beings. Human beings are not always punctual. See, if your class is at 9:30, you will always come at 10 o'clock or 9:45. You will never come at 9:30, right? This is the nature of human beings. But light is not like that. It's very punctual. Okay, it will definitely reach on time, exactly within 5 minutes that the target was set. Okay, so the moment it comes here, the speed of light decreases, no? On time it should reach, but the speed has become very, very less. So what it will do, it will take a short route. Okay, anyway, it should reach this surface. Okay, if it takes the original path is not possible, right? It will bend. It will bend in such a way that it will take a short route and it will try to reach in time at a target. Okay, at a particular point that we set as a target. Okay, so in this case, since the speed of light is very, very less in water, naturally the speed decreases, but what happens, it is taking a shortcut to reach at a particular time. Say for example, your class is at 9:30. Exactly you want to reach at 9:30. But you have found a lot of traffic on your way. So what you will do? You will take a shortcut to reach on time. No? The same thing, since the traffic is very high, water, the molecules are too many. There are no much spaces. So it cannot travel that fastly to reach a target. So that's the reason it is taking a shortcut. Okay, if it takes a longer way, if it takes this way, it takes lot of time. Say this is actually a shortcut to reach this surface. It should reach on time, no? So it is taking a shortcut. Say here what the light is taking, here it is taking shortcut. That's the reason the light is bending. Its direction is near to normal. Near to normal. Got the logic here? Can you compare the logic here? Fine. Same way here. Okay, what happens here is, see, light incident ray has hit at this point. Okay, from this point to this point, if it has to reach within 5 minutes, it's a rarer medium, guys. It's a rarer medium. Okay, and in a rarer medium, speed of light is very fast. No? Speed of light is very fast. Anyway, it definitely reaches. Okay, but it will not like to reach early also. Since the speed of light is very fast, if it can take a shortcut, it can reach within 2 minutes. But light doesn't like to take that particular chance. Light, if it has to reach within 5 minutes, it will reach at the 5th minute only. It will not like to reach at 2nd minute, 1st minute. Though it is possible to reach very much early because the second medium is very fast. It can reach very fast, right? So, but it doesn't like to reach early also. It will try to reach at the same time. So what happens? Say for example, your class is at 9:30. Okay, and you started at 9 o'clock. Within 10 minutes, you can reach the school or you can reach the class. But if you are not liking to reach too much early also, what you will do? There is no traffic also. So what you will do? You will take a long route. Okay, you will make a time pass. And then exactly at 9:30, you will reach your class. You will reach your school. Right? The same concept here. Though the light has a chance of reaching early, it will not reach. Okay, so just to make a time pass, what it will do? It will take a long route. Okay, that's the reason here the direction is away from the normal. The direction is away from the normal. Okay, so this is the reason why actually the light, the refracted ray is moving towards a normal when it is traveling from rarer medium to denser medium, and why the refracted ray is moving away from normal when it is traveling from denser medium to rarer medium. This is the logic. Anyway, this point is not necessary to remember, just to make you understand, to have more clarity, I mentioned this. Otherwise, 2 points are necessary to remember. One is when it is traveling from rarer to denser, the refracted ray is moving towards the normal, and here angle of incidence is larger than the angle of refraction. And here when the light is traveling from denser medium to rarer medium, the refracted ray bends away from the normal, and here angle of incidence is smaller than angle of refraction. So these 2 points, if you can remember, it is more than enough. Okay, and now if you are really a science student, you will definitely get curiosity about the experiments that I have shown in the starting of the class. Okay, ma'am, we got to know what is refraction. Oh, bending of light only we call refraction. But how this phenomenon you can explain for this situation? I told you the straw, when kept in a glass of water, the straw looks broken in water. So it is due to refraction, I told. But how exactly the refraction is involved here? How exactly the refraction is working in this case? Okay, so this point you would like to listen, right? Anyway, this is not there for the examination. They don't ask you also. Just why the straw looks broken in water. If they ask you, the answer is because of refraction. But exactly how a refraction is working here, okay, in-depth concepts and all, they won't ask you. But I would like to tell that here. Since I have shown the experiments, I cannot just say it is because of the refraction. So once you know what is refraction now, and let us see how it is working in the situations that I have shown in the starting of the class. Okay. See guys, normally when do we see the objects? Say for example, in front of me, I have some apple. When do I can see this apple? How I can see this apple with my eyes? It's because of reflection. Yes or no? Say sun rays or the tube light rays. When light rays fall on this apple, okay, if I am standing here, imagine this is my eye. If these rays are reaching my eye, okay, then I can see this apple. So normally speaking, reflection, due to reflection, we can see the various things surrounding us normally, right? And now, okay, so normally how I can conclude is any ray from an object is passing to our eye, we can see that object, right? And now that bowl and coin thing I'll explain you. See, what actually happens is, this is a bowl, here I kept a coin, right? And I am there in this direction. Okay. See, when I can see this coin, see when the rays start emerging, and if this ray reaches my eye, and then I can see the coin. Yes or no? See, if the rays that are coming out of the coin is not reaching my eye, I cannot see the coin. Here what is happening, when there is no water, these light rays that are coming from the coin, they were actually blocked by the surface of the beaker or bowl. Okay, this particular surface is not allowing rays to reach to my eye. That's the reason I couldn't see the coin. But the moment I fill the beaker or bowl with water, what happens? Light ray reaches here, and this is water, and outside I am standing in air, right? Outside atmosphere is full of air. So my light ray is traveling from water to air. That means medium is changing. So what happens to this ray? Imagine this is like an incident ray, the ray that is coming from the object. So the moment it reaches the boundary, it bends, right? It will bend towards my eye. It will bend like this. Okay, since it is bending, say all the rays that is coming from a coin is bending like this. They are actually bending like this. That's the reason I could see this particular coin. Okay, but I cannot make the exact location of a coin. Actually, for my eyes, the coin appears that it is there here. Okay, initially the position of the coin is here, guys. Okay, but inside the water, I could see the coin, and I could see in such a way that the coin is somewhere here. So why is that happening? If I project these lines, they are meeting at this point. Okay, the refracted rays, okay, that reached my eye. Refraction occurred. Bending of light is called refraction. Okay, over. Since the rays have bent and it reached my eye, these rays have to meet at certain point. There I will find my object actually. Okay, so these three rays, where are they meeting? Here, this side they are meeting. They are not meeting back side. Say if I join all these rays, where are they meeting? Here they are meeting. That's the reason to my brain, the coin appears in this position. Okay, so the brain is a big fool, guys. The brain's activity is surrounded by light only. Okay, see, the rays have bent and reached the eye. That is not enough, guys. These rays have to meet at certain point. There you will observe the object. Okay, the image of an object. So where are they meeting? They are not meeting at exact position of the object. They are meeting somewhere here. So you will see your object here, but exactly your object is here. But you are going to see the object is slightly in a different position than the original one. Okay, see, that's how I could see little of the coin when water is poured in it. Okay, coming to the straw thing, guys. Why the straw looks broken here is, see, this is a beaker of water where I kept a straw. Actually speaking, straw is not broken. It is there like this originally, right? Why it appears to be broken is, here is my eye. So what happens? See, light rays from the straw, it's coming like this, and there, the medium is changing. This is water, this is air, right? So definitely it will bend and it will reach my eye. So this is how all my, the light rays are bending and, they are reaching to my eye like this. Okay, and you might get a doubt, ma'am is telling from the object light rays are going out to the eye. What? Object will have a light with it? Actually, see, it's a reflection, guys. See, sun is there or tube light is there. From that, the rays are going to the straw, and from the straw, when it is reaching, if reflection occurs only, we can see. In the process of reflection, when the ray was entering from this medium to this medium, since medium is changing, the bending of light is taking place. Actually, we see the things by reflection only. Okay, light is coming and going to this straw. From the straw, the rays are reaching to eye. And when the reflected rays meet at a point, their image formation takes place. That image we will see. Our brain detects that image, guys. Okay, say I am not talking about the rays coming to the straw. Just to explain why the displacement and all happens. That thing I am explaining you, right? So when the rays start from the straw, since the medium has changed, refraction took place, the bending took place. Okay, and now imagine, these rays, where are they meeting, guys? These refracted rays. Now this is a refracted ray, right? Where are they meeting? Refracted rays inside the water. Drag them and see. See, here they are meeting, here they are meeting. That means the straw which was there here is appearing here. That means the entire portion that is there in the water originally here is appearing here for you, because at this point the refracted rays, these are nothing but the reflected rays. See, from sunlight it has come here, it has gone here. Reflected rays, where they will meet, their image is formed. So actually these rays are after reflection, right? They are meeting here. That's the reason the straw which is there in the water is appearing at this position, That's the reason straw appears broken. Okay, so this is an illusion for your brain. Okay, so light rays are actually playing with our brain here. Got to know? Say, this is the reason why we can see a coin when water is poured. This is the reason why a straw appears broken, in the water. All this is because of originally refraction. We see the things due to reflection only, but in the process of reflection, due to the change in the media for the light ray traveling, refraction is also observed. Okay, so actually how you can see the coin, guys, since here refraction is happening, these rays, where are they meeting? They are meeting somewhere here. That's the reason the coin originally which was here is now here for your brain, so you can see the coin. Yes or no? So here the reason is refraction only, no? Due to the refraction originally you can see, right? Yes, since the rays have changed its direction, say these rays are meeting here. So the coin, if it is here, you cannot see, but if it is here, you can see, guys. Okay, say because of the refraction, apparently, artificially, the position of the coin, image of the coin has fallen here. Okay, so this is what this particular thing is detected by your brain. This is what you will see, but originally coin is not here, coin is here, right? So this is science, this is not any magic. Okay, so this is all the wonders of light rays, that is playing with our brain. Clear? So that's all about the concept of refraction. Anyway, all this thing is for your knowledge and for your curiosity, but for the examination point of view, this is very important, guys. Okay, and you must clearly understand refracted ray moving towards a normal when light is passing from a rarer medium to denser medium, and when light passes from denser to rarer, the refracted ray moves away from normal. These points help us in learning further concepts that we study in our further videos. So it's very basic point one must remember about refraction. Okay, so see you with the next concept in the next video. Till then, keep revising a concept and comment in a comment section whether you have got happy smile on your face or not. Okay, or whether you have understood the class or not. Fine. So do subscribe our channel to learn the concepts in the easiest way and in a detailed way. Thank you so much.